my channel. Uh, Today at J Magics, we will be starting Black Book series. So, in the first episode of Black Book series, I am going to have some questions of the logarithmic manipulations in integration. So, let's look at this question. Now, the first thought that comes in our mind while attempting this question is to expand the square of the given term. So let's do that. This becomes now let's expand actually, right? Now as you can see that here square of ln x square plus 1 is given, and here this term ln square x plus 1 itself is given. So this gives you the feel of the quotient rule. The quotient rule of differentiation, which is actually being performed here. So you get a hint about that, right? Now let's see this question here. So if we consider this as a bracket and in 2 ln x, now we know that here no coefficient of x is being provided with no degree of x. So we can say that here the coefficient would have been x, right? Now if we differentiate this given expression, that is ln square x plus 1, this gives us 2 ln x 1 into x by product rule, right? So we can say that this would have been our function, right? And then the same result, which I will copy from here, right? Right, this was our integration, right? So now we can clearly see the theme being formed here, that is it is the differentiation of x by ln x square plus 1 integration. Now we know that integration of fx dx is equals to integration of d of fx, that is fx only. So we can say that, right, plus the constant of integration of course. So we can say that this terms in fact turns out to be x plus ln x squared plus 1 plus c, and that is our answer to this question, right? So just like that, we solved our first question of Black Book, right? You can take the screenshot if you want. Now let's see the second question. Now this question is one of the good questions present in Black Book, right? So what comes to our mind when we start looking at this integral, right? So we don't know, generally we don't know the integration of x to the power of x, right? So let's consider x to the power of x as t, and let's actually, there are terms of log here, right? Right. So this is a standard, in fact this is a standard technique for x to the power of x, that we take log both sides. By the property of log, we can say that this is in fact x ln x, right? Now let's differentiate both sides. Differentiating both sides will give us 1 by t dt here, and ln x plus 1 dx here, right? Now this t in fact is x to the power of x. So dt in fact becomes x to the power of x ln x plus 1, right? So if this expression has been given, either its differentiation should also have been given, or this term in fact turns out to be the differentiation, right? So let's try to modify this. Our motivation to modify this is this differential we go, right? So x to the power of x, and this in fact you can say that uh, ln of x square, it has no significant meaning here, right? So we can do this, right? Plus 1 by x, 1 by x, this also motivates us to do this because 1 by x is integration of, is differentiation of ln x, right? So we can write this integral as x into ln of x plus x to the power of x into 1 by x, right? Right. So if we look at this carefully, differentiation of x to the power of x into ln x and x to the power of x into the differentiation of ln x is given here, right? So this is clearly form of product rule, right? This is clearly the form of product rule. So we can say that this is in fact the differentiation of the function, right? Where function is x to the power of x ln x, right? So this in fact gives us fx and obviously plus c, right? And this fx turns out to be what? X to the power of x ln x plus c, right? And this in fact is our answer, right? So you can see that our motivation with ln x is so simple, right? Now let's see this question. This question is actually integration plus functions, right? Integrations plus functions. So you can clearly see that there is no such form where ln x to the power of infinity could be modified into, right? But see the limits, right? See the limits. Now you can say that when, let's clearly define the domain and the range for fx, right? As fx we know that this is has to be a piecewise function, right? So when ln x is greater than 1, then ln x to the power of infinity tends to infinity, and fx is x upon 1 plus ln x to the power of infinity. So this turns into 0, right? This turns into 0. So when ln x is greater than 1, that is when x is greater than e, right? Taking e to the power of both sides, right? Now, right? So, and when ln x is equals to 1, ln x to exactly equals to 1 we are saying here, so its power infinity is 1 only, right? So we can say that fx is equals to x plus 1 plus 1, that is x plus, right? Now when ln x is smaller than 0, right? So when ln x is smaller than 0, we know that something to the power, something that is greater than that is smaller than 1 to the power of infinity is always tends to 0, right? So we can say that this in fact becomes fx is equals to x plus 1 plus 0, right? That becomes simply fx, that implies simply that fx becomes equals to x, right? So fx becomes equals to x, right? So now let's break it let's write it, sorry, let's write it as a piecewise function. So fx is x by 2 when ln x is equals to e, that is x is equals to e, and it is x when ln x is smaller than 1, that is x is smaller than e, right? Right. Now look at this integral. Let's term it out. As fx is a piecewise function, then I would also have been a piecewise function. That is clear, right? Now let's see the domain of fx. It is when x is smaller than e, right? And x is obviously the range of for the domain of ln x is x belongs to, right? Right. So when x belongs to 1 to e, right? Because at e the limit is breaking 0 otherwise, right? Otherwise, better than otherwise, we write, right? This becomes what? This, right? This becomes x x dx plus e to e. This becomes 0, right? 0 as we know that, right? Let me get it clear, right? So uh, sorry, this becomes 0 and this becomes x squared to the power of 2, right? We know that, right? So it's pretty basic, right? This is pretty basic, right? So from 1 to e, and that becomes, right? And this is our answer, right? Now, look at this question, right? It is a good question, I would say, and a great example for logarithmic manipulation, right? Our first lecture was about logarithmic manipulation. Yes, this was our question, right? Now look at this question. We know that we don't obviously know exactly about this integral, right? We don't exactly know exactly about this integral, but you can see that an interesting manipulation in case of ln x. What is that? You can see that I is equals to 0 से infinity ln x dx, अगर if we write, right? So if we not like this, so if we write, if we convert x into 1 by t, if we write, let me do that correctly. If we write, if we substitute x to, right? So dx becomes 1 is t, right? But when you see this ln x, this ln x becomes 1 by t, that is minus of ln t, right? So I becomes, limits we have to change, this becomes minus ln t into, right? So this becomes minus ln t into, right? So this manipulation is very helpful in our in some of the cases, right? So we are going to do the same manipulation. So we are doing substituting x equals to 1 by t, so dx becomes minus 1 by t square t. This becomes infinity to 0, we know we have to change the limits, and this becomes minus of ln t by the properties of logarithm, 1 by x square plus 4 and 1 by t square minus 1 by t square dt to 0 minus of minus and minus, this minus cancels, and we get our result the ln t 1 plus 4t squared. This t square goes here, this is 3 square dt, this terms cancel, right? So I can just cancel out these terms, bring it, right? We got our, this is also equals to e, this is also equals to e, right? So now we can change the variable, right? मतलब right, मतलब मैं इस वो x लिखूँ या फिर 1 by t लिखूँ या x लिखूँ तो उससे कोई फ़र्क नहीं पड़ना चाहिए, right? So this is our integral and this is also our integral, right? So let me just do one thing, let me bring this integral here, right? So we have these integrals. Now first what we have to do, we have to one more substitution we have, right? There are many more ways to do this question, which is not in our syllabus, but I am telling you the method which is in our syllabus, right? So we can substitute uh, x as x by 2 here, right? So what this does is ln x minus ln 2, right? By the properties of logarithm we know that e by b is equals to ln a minus ln b, right? And this becomes 1 plus x squared, and this dx becomes dx by, right? How we did that, we just we are converting it, so this becomes b as this becomes this, right? You must have learned this, did this kind of manipulations in your physics, right? Physics, we do these kinds of manipulations, right? So this is also equals to I, this is also equals to I, right? This is also equals to I, and let's see this integral. If we say let's substitute now we have to do something common here, so we substitute x to 2x, right? So this becomes ln x plus ln 2 into 2 dx, and 4x square plus 1, integration remains same, and this 2 cancels out from this 2, this I becomes 1 by 2, 0, this ln x plus ln 2 x square plus 1 dx, right? So this is this was our first manipulation, this was our second manipulation, right? So what we have to do now, you can see that if we change the sign of this integral, right, what we have to do, we have to change the limits of this integral to 0 to infinity, and sorry for the handwriting, this becomes ln x minus ln 2 ln of 2 by 1 plus x squared dx, right? So this is our first equation, this is our second, right? So let's actually take them here, right? So we are adding these two equations, right? So when we add these two equations, we get uh, 1 by 2. Now as we can see that this minus turns this negative, this positive, and when we add this ln x get cancelled, and we get 2 of ln 2, 2 times ln 2, and right, this is our 2. This 2 and 2 cancels, I becomes half of integral half ln 2 and this. Right. So now this is a standard integral. This turns out to be nx from 0 to infinity into by 2 tan of infinity, we write here minus tan inverse of 0, right, tan inverse of 0. So we take them here, let me take them here, right. So ln of 2 here, and this tan inverse of infinity, we know that the graph of tan was this, supposed to be graph of tan, right. So at pi by 2 it tends to infinity. This is also not exact, infinity is never exact, so we can write this as, right, and tan inverse 0 is obviously 0, and this gives us ln 2 pi ln 2 by 4, right, and this in fact is our answer, right. So this obviously is method, one method to solve it, right, one method to solve it, right. If you want another method to solve it using things that are not related to JEE syllabus, beyond JEE syllabus, right, beyond JEE syllabus, right, but just for fun, then you can search residue theorem, and you can study that method from residue theorem can also be applied in this question, right, right. So thanks for watching. I will be back with another black book series. Do comment if you want anything else, right. All the best for your preparation. Bye bye.